So we have already solved this problem. We have calculated the support reaction, and then after we have drawn this bending moment, drawn this shear force diagram. Okay, so this is the SFD of a beam. So we know the reactions, we know the SFD of the beam. Okay, so we have to calculate only the bending moment diagram. So this is the third point to calculation of BMD. Calculation of BMD. Okay, and at this point, that is nothing but this point C, there is an internal hinge. So now suppose this is the reference line for drawing the BMD of this structure. Now let us calculate the bending moment at point B. So bending moment at point B. We know the sign conventions like this. This is positive and this is negative. So while we are calculating bending moment at point B, just consider let us consider the bend to the right side. Consider the right side from the point B. Okay, so we are taking at the right side from the B, so it is in anti-clockwise direction, so that will be considered as positive. So bending moment at point B is positive 20 into 4, and it will rotate in anti-clockwise direction like this, so that's why it will be negative. That is 20 to 2, that is 40, and it will act at a distance of almost 3 meter, because this will be the point of application of this load. So 20 into 2, that is nothing but a 40, and 40 into 3. So 20 into 4, that is 80, minus 40 into 3, that is 120 kilonewton meter. So the difference of these two is nothing but 40 kilonewton meter. Okay, so that will be the bending moment at this point, and it will be negative. So this is the point B, and below that the bending moment will be 40 kilonewton meter. So we know this point. Okay, but as I have already told you that when there is a change in a shear force, then there will be the maximum bending moment at that point. So here in this diagram there are 2 points where this inclined line is changing this sign. Okay, shear force diagram is changing this from positive to negative. So at this point there will be the maximum bending moment, and at this point there will be the maximum bending moment. So we should know what is the exact point of this. Okay, at how much distance from point D this is zero shear force is there. At that point we will calculate the bending moment. So to know the point of zero shear force from D, so we know the sign convention for shear force like this. This will be considered positive, this will be considered as negative. So we know this. So at this point, let us this point be E, and it is acting at a distance of x from the point D. So this is the point E. So shear force at E is, we know that at E shear force is 0. So considering right side of the section, so there will be the 20 kilonewton force which is in upward direction. So it will be negative. It will be negative 20. Okay, and this force is this 20 kilonewton load acting on x distance. It will be acting in a downward direction. So that will be right side of the section in downward direction, which is acting in a downward direction. So that will be right side of the section acting in a downward direction, so that will be 20 plus 20 into x. Okay, so that's why this minus 20 goes this side, become 20 and is equal to 20x. So 20 20 get cancel and x is equal to 1. So it means that the distance of 1 meter, okay, at the distance of 1 meter the bending moment is maximum. So let us calculate the bending moment at that point. Okay, so now the bending moment at point E. Okay, so this 20 kilonewton force is going to rotate in anti-clockwise direction, that will be considered as positive as per the bending moment sign convention. So that will be positive 20 into 1, you know that. And again it is acting, this load acting 20 kilonewton per meter on 1 meter length is again in clockwise direction, so that will be considered as negative. So it will be negative, that is 20 multiplied by 1 multiplied by, it will act at a distance of 0.5, 20 into 1 into 0.5. So this is 20 minus 20 into 0.5, that is nothing but 10. So 20 minus 10 is nothing but 10 kilonewton meter. So this will be the bending moment at this point. So at point E there will be the bending moment of 10 kilonewton meter. So we know this. Now again here there is a point of zero shear force, no? So let us look it to know the point of zero shear force from point A. To know the point of zero shear force from point A, let us consider this point as F, and let us consider it is acting at a distance of x from A support. Okay, so we know that shear force at F is 0, we already know this. So consider the left side of this portion and calculate the shear force. So left side in upward direction it is considered as positive, so that's why 30 will be positive. 0 is equal to 30 minus 20, as right side of the section, left side of the section in downward direction, so left side of the section in downward direction, so that's why it is considered as negative, minus 20 into I think x. Okay, so we have considered this distance as x, so 20 into x. So minus 30 is equal to 20x. So this gets cancelled, 3 by 2 is nothing but 1.5. So at a distance of 1.5 meter, okay, so the distance at 1.5 meter, the bending moment is going to be 0. So let us calculate bending moment at point F. So we are calculating bending moment at point F now. So bending moment at F is nothing but, it is in anti-clockwise direction towards the left of the section, so that's why 30 into the distance 1.5, this moment will be considered as a positive, 30 into 1.5, and on the beam there is a UDL of 20 kilonewton per meter. It is acting in downward direction and it will be produce anti-clockwise movement. Okay, so the left side of the section in anti-clockwise direction, so that's why it is minus 20 into 1.5 into 0.75. Okay, half of 1.5 is 0.75, so that's why The bending moment at this point will be 22.5 kilonewton meter. So at this point we got bending moment 22.5 kilonewton meter and it is positive. Okay, so that's why locate this point like this, that is positive 20 kilonewton meter. So we got all the points of bending moment. As there is UDL over the length of this beam, okay, so and it is inclined line, and up to this portion there will be a 2-degree parabola. So up to point C, this is 2-degree parabola. Then there is not any load over this section, okay, no load, so that's why there will be a straight line variation up to this point. At this point the bending moment at point B we have already calculated, that is 40 kilonewton meter, so negative, so that's why it will be joined by straight line, so it is 40 kilonewton meter, and this is, as we have calculated, that is 10 kilonewton meter. Now again there is a UDL all over this span, okay, there is a positive bending moment at this point, so all over this length there will be a 2-degree parabola. So let us draw it like this, okay, so this is 2-degree parabola, and bending moment at this point is 22.5 kilonewton meter. So this is the BMD for this calculation. Okay, so this is how we have to draw shear force diagram and bending moment diagram. The only difference in this problem was that at point C there was hinge, and at a hinge, as we know, the as hinge allows the rotation, the bending moment at hinge will be 0. So that we got additional equation, so that's why we could analyze this beam. Okay, so thank you.